Hello, Terry.
Hello.
Hear me okay?
Yep.
Yeah, I'm not sure who else will be joining us today, but I'll probably give it a few minutes. I saw you opened a few and commented on a few things. I hadn't had a chance to go back over it. A bit of a hectic week.
Yeah, so just a little bit about structuring the tables so that for the technical requirements table, we need to not solutionize in that particular table, but we can put potential solutions in the narrative for the solution section of the document.
Can you maybe share screen just to show me what you mean by that? I'm just a bit lost.
So on this one, you added some stuff in to this section which had some potential solutions in it.
Mm-hmm.
And if we actually open the file, so what we've got is the three sections, which are the challenges table, which is what's the problem. Then we've got the technology requirements table that we're updating at the moment, which is what are the technical requirements that are implications of the problem domain.
Okay.
And then
yeah,
the final section, we have the map itself, but we also have the ability to put a narrative in here, which discusses potential solutions for some of the technology requirements.
And does that map one-to-one with the stuff in the technology requirements section?
Well, conversationally, yes. I mean, we could put a table in there, but really the purpose of the roadmap is to be indicative of the problems, but not to be too prescriptive about how we solve those. So, you know, we can make suggestions in the potential solutions narrative to discuss the ways in which you might leverage existing technologies to solve particular requirements. But in general, you wouldn't be prescriptive about how to address a particular problem unless there was a very, very clear need for a global standard in a particular area.
So I'm trying to think of what's an example of an ideal entry there. Right, yeah, I see, yeah. So it's almost like that right column is fleshing out the requirement and basically justifying it.
Yeah, so if we go to one of my PRs,
it's not ideal reviewing things in content in GitHub. I don't display the rich diff. What does that do? Oh yeah, that's better. Nope, rich diff.
So I've been working further down the table on some of the future challenges, and what the way that I've written these is phrased as requirements, but have left the solutions sort of open to multiple approaches.
Mm-hmm. That makes sense. Looks good. So in your PR, if I click the display the rich diff, not really seeing what the diff is. It's not. Oh, hang on. No. Yeah. So that looks good. That was good. Yeah, so I'll reword it to my changes. I wanted to look at things anyway to be less solutioneering.
Yeah, I think it's only a minor change, but I just want
yeah,
us to have a
it's so tempting to go, oh, if we use Git and we do this, then, you know,
yeah,
Armwave, all of this stuff is not a problem, but that's kind of, that's a potential solution in the section below.
and you're welcome
might
to take that stuff and add it into the just as a paragraph in the final section, and we can tidy up the structure of that as we go along. So you know, you can use that as a notepad for various pieces if you want. You know,
right.
There's no harm in us starting to work on that as well.
So when this roadmap sort of started, I don't really know the background of it. So is there a backstory for this? Because I know this SIG was going on for a little bit before. Like, what prompted to start this? Do all SIGs have some sort of a roadmap thing like this? Like, what's the backstory?
So the grandfather of road mapping is the IEEE IRDS roadmap, which is the primary roadmap that drives the semiconductor industry. So that's the engine behind Moore's law, and I sit on a couple of the chapters of that roadmap.
And I use this type of format.
Together yeah.
Right. All right, cool. So yeah, I'll keep working down that list. So that makes it a bit clearer. So we got a few other people joined. Kara's joined. I don't know if Kara's joined this one before, but could be in the other one. Hi, Kara and Esther. So no colleagues from New Zealand today, but that's all right. So when I'm just going to the agenda, I'll paste the link into the agenda. Can do a chat here, so that way everyone gets it. So the agenda there. I did see an interesting article I pasted at the top of that agenda, which seemed topical this week, was on a AI-based medical algorithm favoring white people without race being part of the training set. So I thought that was a topical sort of thing, and I know something Terry talks about a lot. This had no ill intent at all. but you know, the correlations and all that sort of stuff was all unfortunate, and they corrected it. But I thought that was one of the things talked about in the roadmap, is the importance of bias and awareness of bias and things like that. And I'm sure it's not surprising to Terry, but this was kind of surprising. It's like, when you look at it, it's like, well, of course it could do that. That makes sense, that if there are systemic things going on, then a historically trained model would probably encode them. So I guess the way you would counter that would be, you'd have some, well, I guess almost like test-driven development, you'd want to have some criteria or some analysis you do on any sort of model, whether, or even if it was handwritten code, that it wasn't you know, doing things that would challenge what you thought. Like, I guess people assumed it would just be fair, being based on historical data. But I thought that was an interesting link to include, because it's like, it's just evidence. So I don't know if things like that, do you think that belongs in the roadmap, like a article sort of justifying things like that? I'm sure there's probably better examples, but I thought that was a novel one.
I think we might want to just expand on some of those things in the narrative. I'm not sure whether we want to tie too many references in the roadmap.
Yeah, maybe it's more just for, like, it could be a link in the narrative or a footnote or something, like, for example.
The other risk is that, obviously the intention is that these documents are advisory documents that are meant to set the guidance and standards for people. But if you link them to third-party documents, then you run the risk of abuse through those third-party links. So
yeah,
that's true. There's a challenge there in terms of how we manage the integrity of the content that we're promoting.
Yeah, I think it's fine to have it in the meeting notes. That sort of gives people something to look at, because people do, I've noticed throughout the week, there's always several people have it open. So looking, I just thought that was interesting. Looking also at last week, there was a bit of a discussion about long-running training and checkpointing. And I left a note to talk a bit more about it, but I don't really have much to say yet. That seems probably a bit further in the weeds than we want to get.
So I think that's probably something that deserves a section in the technology requirements. So we should spell out the fact that there is an issue there in terms of, we're dealing with long-running processes, and if those processes fail, then are we forcing people to restart from the beginning, or are we enabling continuity by recovering back to a previous known good step?
All right. I can add that. I'll take that on. Yeah, it's something I've been experiencing myself, like just I guess someone coming from a more data science angle is probably used to working that way, conducting experiments and that, but from more of a developer angle, I find it quite frustrating when these things take hours, and in some cases you're saying days. Like, it's immensely frustrating from a productivity viewpoint. Part of that might be a little bit just, that's just the way it is. Like, if you're going to be training, learning an algorithm as opposed to writing it, then you've got to let the machine do the work. But, as a person that needs to sort of focus and avoid switching context, it's quite jarring. So it's probably worth calling out.
So, I mean, it might help to give you a little bit of context around some of the larger projects. So if you look at a sizable machine learning project, like, say, training an autonomous vehicle, you're gathering petabytes of training data, which you generally have to try and compress down to hundreds of terabytes for it to be even feasible to move them around enough to be able to work on it. But you're still looking at a situation that if you were using a single machine, it's going to take you about 2 years to run a single training event on the volume of data that you've got. So you then have to decompose that training into multiple parallel subtasks that can be executed simultaneously, with a view to realistically being able to get your workload down to under a week per training run. And that might be an entire data center dedicated to running that one training event. So if you look at the granularity of the equipment that you're buying at that stage, if you look at the NVIDIA rig, they have a supercomputer offering where a single deliverable chunk is just over 1,000 GPUs, that takes up like 8 or 10 full racks in a data center, and you can then start stacking those things together to give you enough compute capacity to operate at pace. But the whole thing is effectively I/O bound, because a single GPU card is the minimum unit of computing, and it only has 40 gig of memory on it. So you typically it's able to chew through at least 10 gig of data per second. So you can cache about 4 seconds worth of processable data on the card. So you're having to move your multiple petabytes of data continuously through this computing infrastructure, and the whole thing is limited by the PCIe bandwidth and the bandwidth of the network infrastructure that you've got.
So another thing that we didn't talk about, which I'd like your view on, was this library from David from Microsoft. I didn't know whether that was kind of relevant to checkpointing, and I think the idea was to have sort of standard metadata formats or YAML formats. So when you configure a training run or some step of things, then it writes it out to disk in a standard format. Did you see it as relevant to that, or it's a bit off to the side?
So again, that's something that can go in the potential solutions section. And we might want to expand a bit more on the requirements. I think we've got some discussion about the need for using metadata to version large data sets, because obviously if you've got a petabyte of test data, you don't want to create multiple instances of that and keep them all hanging around.
Yeah, I wasn't sure how relevant it was to that, but I'll have a look and if it makes sense, add it in. So one of the other things I wanted to flag to bring up that I've been looking into, and I don't know how it relates to this roadmap, is reinforcement learning. So and unsupervised learning. So sort of the other families of machine learning, like a lot of, maybe I'm misunderstanding, but a lot of what I've read seems related to supervised machine learning, which is very relevant to business settings. But I'm sure there's a lot of the same technologies in use for unsupervised scenarios, which might be using the same underlying technology, but the way they work is quite different. They're looking for clusters of things, or maybe they're dealing with more regular streaming data. There's no discrete, okay, we've stopped training now, we're now deploying or A/Bing the model, or checkpointing the data. And reinforcement learning's, I guess, a more complex thing again, but maybe it's a little bit more niche in this setting. Mostly that's in robotics or games from my understanding, but like how much of this roadmap has to sort of spread to those other areas?
I think it probably helps to think about this as three different strategies on a continuum.
Mm-hmm.
So you've got the type of supervised learning that we've been looking at today, which is kind of equivalent to a human academic training, in that you do it once at the beginning of your career and then it's over.
You apply it again and again, and maybe
Yeah.
refresh every now and then. Yeah.
So that's definitely a compile time activity. Then you've got sort of sequence-based reinforcement learning, which is a little akin to the human sleep strategy, which is where you get exposed to a bunch of new training data every day, and then you shut down overnight and learn from the new data, and that modifies your strategy for the following day. So that would be an iterative recompilation in a programming metaphor. So you'd retrain once a day, and then deploy the new model in your downtime. And then the third one is continuous learning, which is more akin to self-modifying code. And it's that third one that really falls outside of the CI/CD model, because it switches from being a controlled compilation to being a runtime operation, which is intrinsic to your intellectual property.
Mm-hmm. Just take some notes. It's good stuff. So reinforcement learning would come under continuous learning?
Not necessarily. You can run reinforcement learning in an iterative sense by gathering the new data and forcing that to trigger a new training episode as part of
a yeah. That's that you've got this slightly, that's a tidal loop. That's sort of what I'm doing, but it's myself. But I'm thinking. So I'm trying to think of the things I know of that fall outside of MLOps. Like, so did you say the second one that was more akin to day-to-day human learning was unsupervised, or
yeah? So you're going to get examples of unsupervised and reinforcement learning that can be run in that way. So the difference really is whether you're doing iterative or continuous learning. So if we're doing iterative processes, then that fits within the CI/CD model of the world. But if your solution is continuous real-time learning, then that puts you in a very different category, and at that point you're not really operating within an MLOps model anymore,
right?
Because you're going to be treating that as part of your intellectual property rather than part of a sort of unified build process that you use to build your intellectual property.
I'll just take some notes.
So Terry, in your opinion then, is this roadmap and what we're talking about here, is it more relevant to the first two cases and less so the continuous one?
Well, I think what we'll find is that you're more,
which is a bit ironic with the name, I know, but I understand the meaning here. It's funny. Yeah.
but you're more likely to find people working collaboratively on shared solutions in the first spaces, because it doesn't impinge directly on their intellectual property, but it does accelerate their ability to generate intellectual property. Whereas in the third case, the continuous learning is, you're intrinsically, the way you do continuous learning forms part of your intellectual property. So people are more likely to be building dedicated platforms to do that. Now, they will.
Can you talk a bit more about what you mean by that intellectual property for the third case? I'm still trying to. Could you expand a bit more on that? I'm still a bit lost.
Well, if what you're doing is having something that is modifying its own hyperparameters in real time, then you're going to have to control that in some specialized sense above and beyond the way that you would build your models if you were doing it.
What if you were using maybe something that could be a supervised technology, and you wrapped things around it so it, like AdaNet and other things, and continually tweak the hyperparameters in your own special source way. And it was always learning, but it was still checkpointing. It would do it, once an hour or once a day, once a week.
Well, if it's
would that still qualify as
doing it iteratively on a cadence, then you're able to do that with the conventional sort of CI/CD approach that we're proposing.
Okay, that makes sense. Okay, whereas otherwise it's all basically, if it's tied up in the runtime.
Now that's not to say that you couldn't extend the CI/CD environment to make it into something that would allow you to do that, but my expectation would be that would be more intrinsic to a particular application, and so there would be less opportunities for people to share their approaches in that space, because that's where the secret sauce is going to sit.
I mean, my understanding of things like that is like underneath, there is some level of sharing. Like anomaly detection with neural networks still uses a lot of the same technology as supervised learning. They just structure the layers differently, where they compare the input and output and see whether it's expected or not. So there is some sharing going on there. I guess another type of continuous learning would be things like anomaly detectors. Amazon have random cut forest and Kinesis. You can use that with a few lines of SQL in one of their apps, and there's no iterative thing to that. It's just a window of data, and it's just doing its own modeling on it. And there's other things like that. So I guess they to me, that fairly clearly doesn't fit in.
There's also a challenge here in that continuous learning is effectively ungoverned. So it's very high risk, because it's it's exposed to things like instantaneous forgetting. You can overload it, and it will unlearn stuff spontaneously and start to behave irrationally. Whereas if you're doing iterative retraining, you've got the opportunity to run all your regression testing before switching on the new aspects of the system.
Right.
So my expectation would be that in practical examples, we may find that rapid cadence iterative deployment
is superior.
Yeah, or is certainly amenable to more governance and therefore a lower risk organization.
Yeah, and given it's using the same or a lot of the same algorithms underneath, that's my understanding in sort of researching in the areas. A lot of it's very similar. There's some secret sauce out there, but it's still, they're using a lot of the same techniques. So I guess an analogy for traditional server software, for example, would be you can mutate your server in place. You can update things on the fly. Sure, you can have technology to do that. You can hot swap things in Java. You could do all sorts of technology. There's Smalltalk. There's so many technologies out there to do that. Or you do something that's more rigorous, like Canary, or progressive rollout of new versions of things or features where you cut the traffic over progressively and track error rates, or A/B test it, or have the ability to roll back.
Yeah.
Pretty much everything has moved in that direction, of having that ability to turn things on and off and flick back and forward, lowering the risk in other fields. So I guess you're getting at, well, in the machine learning field, maybe that analogy still holds, where it's we've learned this lesson elsewhere. Like you don't concurrently SSH to 5,000 PHP servers and update things. Like even Facebook at their scale, they do progressive rollout of pre-made blobs of things, even though they're doing it multiple times a day. Even Amazon with their famous every 11-second deployment, they're all atomic things. They're not mutating in memory sort of things. Maybe there's some niche cases where that applies, like maybe in a game engine or something like that, like where it's learning from the user playing or something like that, very sort of in place things where it's learning. Maybe that's more reinforcement, but it's completely coupled to the environment that it's running in. And once that program shuts down, it has no meaning. Yeah, I don't know how that relates to governance, because what if that thing's doing something important and you couldn't explain how it made its decision because it was all done in memory?
And I think this is going to be an interesting one, because if we build the type of infrastructure that the roadmap is suggesting, then you're actually creating the possibility to do evolutionary modeling, where you're creating multiple instances of similar models in parallel, having them compete against each other in a sandbox, and then Canary releasing or AB releasing the more successful models, which would be a much safer and more effective strategy than betting the farm on something that's going to learn on the fly, but with the potential of it doing a Microsoft Tay and becoming a racist fascist.
Yes.
Yeah,
and I guess there is, I don't know the specifics of it, but there is transfer learning. So if there was things learned by I'm trying to think of a case where you would be swapping out a new model with an old, and you want some of the state of the old model to exist in the new one. Maybe
not. And also, I think we're thinking in terms of what people are doing today at small scale, which is building a single instance of a model. But actually, the medium-term picture is that what we're really doing is training lots of smaller models that focus on sub-features within a bigger problem space. And really what you need to do is tune each independently so that the overall behavior is emergent and richer, because that's the way that intelligence works in the living world.
Right.
And we already have that at a functional level, because to run the inferencing on large models, you're having to split it up into lots of small components that are being run independently on separate physical hardware. So a lot of what we're going to be doing is optimizing that process and making it easier to manage as a set of correlated assets which can be deployed and controlled.
Yeah, that's good. There was one other thing which I haven't looked whether it's in the requirements, which was explainability of decisions. Is that mentioned?
It's in the challenges table, yeah.
Probably need something in the. So from your experience, when people say explainability, like what are they really looking for? Like if you imagine it was a model that, not a model, just a bit of code that's continuously delivered, and a decision's made by it to approve a home loan or not, and people ask, well, why did it decide to approve it or not? Like someone's written those rules into code, and it's probably spread across multiple services. Like what do people mean by explainability?
I think this is a very difficult area because there's a difference between what people mean from a political perspective and what it means to a data science in the context of a particular machine learning approach. So, the expectation at a political level is that, we can just introduce some legislation that says all models must be explainable, otherwise you're not legally allowed to deploy them.
Yeah, that could mean anything. Like it's and nothing.
And the challenge is that in many cases things are not going to be explainable in any way that makes sense to a human. Because if you're looking at a neural network, then yes, you can look at the weights of all of the nodes involved in a particular decision, but that's not going to tell you anything, other than a decision because of these weights. Now, the some of what's being done in explainability at the moment is actually keeping a history of how the model was constructed based on the original training data. But that introduces a trade-off between explainability and privacy. Because at that point, you actually have to be able to say, well, we ended up with this model making this decision because of this piece of data that we got from this person. So the more explainable a model is, the less privacy there is in the model.
Right. So if you're using training data as explainability, then you potentially have privacy issues.
Yeah.
Because if you say, well, I can explain how I came to this decision. Here's my set of training. Here's my hyperparameters. Here's all this. You can go and reproduce it, get some graphs, analyze. But to do that, you're basically giving away, the crown jewels, so to speak. That's the training data. Would another, like some algorithms can print out weights of what for a specific decision of what inputs affected it. I think for a lot of people that would be that's a fairly human sort of thing to do, but not all algorithms support that. But I've seen some that do, because from a human point of view, you've got a bunch of features that drove the decision, and it was to do with zip code and a few other things. Then you might not know everything else that went on in the neural network or all the training that made it to get that way, but you can understand, okay, it was because of these three factors. Okay, that maybe makes sense to me. Or this other one was approved and it's because of these 5 other factors. Because that's how a human would explain, like you go, well, you know, why did you make that decision? Why did you reject that PR? And you know, you could enumerate a few things. There'd just be a few things that you'd say, and then the other person go, yeah, that explained it to me. That's enough. Like it seems very, very subjective, but just, I guess, showing the main features that drove the thing would be a less privacy infringing way.
Well, I think the problem is that we don't actually have that level of explainability when humans are making the decisions. You know,
Say that again, sorry.
We don't have the same level of explainability when decisions are being made by humans, but we may believe we do, but in many cases we actually find that decisions are being made for, you know, unconscious reasons rather than based on a fixed set of rules. You know, you've only got to look at the situation in the US this week. You know, why are police officers shooting unarmed civilians in the face? You know, that makes no sense whatsoever if you run through the set of rules that you expect those public officials to be running. So how do you reconcile that from an explainability perspective?
So
this is the bigger challenge for AI, is that right now we're setting the standards for AI much higher than the standards we set for ourselves in the same situations.
Is that fair enough, you think? Like that's...
Well, I think it's to be expected. You know, we're always more cautious when it comes to new things. But the challenge comes in the fact that if we don't know how to set how to work out explainability for natural neural networks, then intrinsically we don't understand how to do that for the artificial ones we're creating either.
Right. Yeah. Yeah, it reminds me of sort of stories in the past where companies would go through a stage of taking a business process that was human driven and theoretically rigorous, and then making it digital, either using a rules engine or just, you know, methodically hand coding it, and then things wouldn't work. There were inconsistencies and illogical states things could get in, and they would blame the software and the technology, but really it was fundamentally flawed all along. It's just that the standard was higher. You expected it to work because you were doing it new. It should have worked fast. It should have been free of bugs, but it's like fundamentally it was not right and never was. So in some ways here it's asking a little bit of the impossible. Like,
so I mean, the classic example of that is, you know, I've worked on many government projects implementing public policy in technology. And when you get down into the detail of that, you usually discover that the policy itself is internally inconsistent. So you cannot apply the policy without violating the laws of physics. And thus you end up in a situation where humans appear to be running the policy because actually they're selectively choosing to ignore it in order to get things through the process. But you can't build a system to implement the same policy because the system is too strict in trying to adhere to the rules and therefore can't actually process anything. And so this is what we're going to see as we move into more you know, machine learning driven decision making, is that we're going to start to see the machines reconciling things in the same way that the humans do, but not necessarily in a way that actually aligns to the policy that you thought you were implementing.
Mm.
You'll model the behaviors, not the intent. And this is why we have the problem with bias and fairness and things like that, because you're actually modeling what people do, not what you wanted people to do.
Mm.
So this is my first time on this APAC call. So I don't know if you've discussed this already, but that idea of bias, how that was explained to me as a way to handle it is you always need a human in the loop. I mean, you're relying on that human quite a bit, but you do need that human checking to make sure that your model is not diverging or it's not giving you undesirable side effects.
Do you mean in the loop, as in for like the CD sort of loop?
Yeah.
Right. Yeah. Not necessarily an individual decision, although for some business processes that's probably reasonable. But say if it's a self-driving car, then like every decision, then that would mean it's not autonomous.
No. So thinking more about bias, but even with self-driving cars, like probably ultimately want a human and have some power in that car anyways. But like with a system that's producing bias, you need to be able to have humans watching it and saying, no, shut it off, like not working, we need to correct this. And that needs to be acknowledged as part of the process, that you need that check.
Mm-hmm.
And I was just wondering, have we addressed that in our how bias will be handled, especially if you have this evolutionary model where you have continuous progressive deployments of different parts of your overall model, and then how they work together and how all those decisions are being made, and then how it comes together and the ultimate functionality that you have. Are we addressing how different checks will be in place at different parts?
So the human in the loop argument is typically one that's used to excuse the need for vendors to be legally responsible for the decisions of their AI systems.
Well, that's like in the self-driving car in Tesla, you got to have your hands, on the wheels, or the lane assistant ones. There was talk of Volvo having a one where if you're on a certain motorway, it would take control and then legally take liability for it in certain criteria, but that hasn't happened yet. But yeah, I think
so.
Certainly,
the challenge is that practically that quickly falls down in the real world. So the classic example of that is the number of people who follow the instructions of their sat nav and drive into rivers, because people quickly become blind to the actual situation and just do whatever the computer says regardless. There's a meme floating around that you might have seen, which is a security guard outside a football stadium, ostensibly patting people down for weapons.
I've seen that.
Waving his hands around the line of somebody without ever touching them. So it's theatre to apply to conform with some legislation, but it's not actually doing the job that it is intended to do.
I mean, we went through a similar thing with, I guess, continuous delivery. I know I've heard of customers and users out there that when they first built their pipeline, they would have a dozen, not checkpoints, but, input stages, for human input stages. They'd start with a dozen. Like, this is a bank. I can't remember which one. It was a European bank. They started with a dozen because that's kind of how they used to work, but they'd put it all in one pipeline. So it was all visible, reportable, and so on. And then they got it down to 3, over a 10 to 12 month period. And they were pretty proud with that, and actually used that as a measure of progress towards continuousness, because they actually thought they needed the humans in the loops at these steps, but then they realized what they were doing, they could automate that away and put checks and guards in. And I wonder if it's not a similar sort of thing here, where maybe for comfort, people will want that and liability reasons, but in time, if we can address the bias issue, which is probably the most serious one, the solution doesn't necessarily mean having a human around always. Not that you want to take over from the humans, but you can like that example I brought up at the start about that healthcare issue. That's something that, had they thought about it, they could have, had acceptance tests or behavioral tests built even while the model was being developed to ensure and test data to verify, so it wouldn't have even been deployed. Like it wouldn't even pass the test. Like there seems to be other ways to address that.
In many cases, the bias actually comes back to how you're structuring the training data. So if you're running a process to validate that you have a representative set of training data, then and a representative set of test data, then you're heading off most of those risks before you even run the training. So the challenge typically comes in those places because the available training data that has insufficient information to represent the customer population. So you're only training for part of the problem that you're trying to solve, and then it doesn't behave the way you expect when you deploy it into a larger population set. So in many cases, you can actually determine before you even start the project whether you're going to have access to sufficient training data to be able to train an unbiased model. So if you've only got access to a hospital data in a predominantly white district, then you can tell in advance that won't generalize to the whole population, because it won't have sufficient training data in it.
Yeah, so the Kara's question is like about bias. It's mentioned right at the start of or near the start, like a few times. So, but it's one of the big things that sort of prompted MLOps, I guess, fairness and bias. So I think there's awareness of it, but that there is a requirement under drivers like enabling automated bias detection testing. So I don't know what that is. Is that a requirement or?
So we really, what we're talking about here is some governance gateways in the release process to be able to ensure that you have done some level of bias detection during the process. Now that might be, a manual sign off to say that you've done an audit on the data and you consider it to be sufficiently broad to meet your requirements, or it might be that you're retaining a set of bias-related test data which doesn't exist in your training set, and then you're using that to measure the response of the model to known scenarios to detect bias and fairness. So typically there's a lot of this that can be automated as long as you're setting up a reasonable profile for the test data that you're applying. And I think what we will see is an evolution of some common standards for what bias assurance should look like. And we're also already seeing a number of independent assurance companies offering this as a service. So in the future you'll be able to go to one of the big four and get audited on fairness and bias for your machine learning solutions, for example.
All right. Well, I think we got some stuff to follow up for the next fortnight. I've got a few more sections to add in. I'll just make a note on and then just so we've got it on the record. And if you had more thoughts, Cara, on bias, because it is a important sort of issue, then can either shoot it to me or add it to as a PR to something if we need a whole section on it, because it will come up. That might be worthwhile. Like that thing I talked about at the start was interesting, because I always thought automated bias would be, oh, you could look at your features and highlight very unbalanced categorical features, and then that would hint at where bias is. But in that example at the start, race was never a feature of that training data set. Yet it learned about the systemic racism in that system without it ever being mentioned. So no automated thing that I thought of would have picked that up. So
so the problem is that you often have proxy features,
right,
which reveal this. So for example, postcode.
Yeah.
So if you have particular regions that are either populated by particular groups, whether that be economically or by demographic, racially, then the system will learn certain things about those postcode groups, and then that becomes intrinsic to the model.
All right. Well, thanks everyone for coming. I've got some good notes. I put them in the doc. As always, share anything in the chat room, and we could talk again next week. I've got some content to add to that and some adjustments to make. So yeah, I'll have a look at that probably early next week and see how we go.
Great. Thanks, everyone.
Thank you.
Good day. Bye-bye.